Hello everyone and welcome to Google Cloud OnBoard. My name is Ify and I'm an instructor for Google Cloud. Today we're going to talk about now our module 2, which is the virtual machines and the storage. Of course, at any time during our live sessions, you can ask questions on our platform and our team is standing by to answer them. So let's get started. So we're going to talk about now the virtual machines in the cloud. And that's very important. But of course, before we actually having our computations, I mean, you guys done a lot of IT stuff before. You done on-prem or you done somewhere else with the cloud. Of course, you know that having a VM, you need the IP. So then what's the IP? That's the network part. So we need the network. So let's see what we have here, which is called the virtual private cloud. You can call it VPC, and that's the network. So what's a virtual private cloud and the networkings? So basically, if you're running cloud and then you kind of believe, oh wow, cloud is public, it's in the internet, and then you kind of believe, oh my God, if I put my applications on the cloud, that means everything on internet? Not really, okay? So those kind of like isolation of the network, that kind of stuff, it's also available that we can do it here in the cloud. So the way we do is called this one, called virtual private. So the virtual private cloud, that's the way you do. So you can have some isolation networks in the cloud. So in a project, basically we know that every single resource attached to a project. So within a project, right now we can have up to 5 networks. And each of these networks, they are all isolated. And every single network, they have their own namespace and they have no IP address range. Of course, we keep some of those specific IPs for us to run something for you. And that of the network, most cool things, it's global. All right. So I think the global part is actually something really differentiate our cloud compared to some of difference. Because right now, here, you know, at Google, everything we do is like a global scale. And of course, the network itself, we believe our customer or our users, they wanted to build things globally. So of course, global and then span to all the available regions. So that means at the same time, when you doing your applications on Google Cloud platforms, and then we are getting more regions, that means you will have your network just automatically expand to those available regions, which is the new ones. All right, and they will contain those subnet, and subnet itself is regional. So network itself is global, and then the subnet is regional. And typically we have some different 3 types. We have default, we have auto, and custom. Now, of course, by the way, we said, yeah, we just talked about the hierarchies, about the organization. We have organizations, we have the folders, which representing different departments and the teams. And now we said, wait, the network belongs to a project. So what does that mean? That means every single project, all those different resources, they are going to stay in different network? The answer is yes, you can do that. Or there's another service, I'll say a feature here that we call the share VPC. So VPC is the network, and then you can do a share. So in that case, yes, that share VPC still belongs to a specific project, but then you can whitelist other projects in your organizations to let them put their resource in your share VPC. And so that's the recommended way that you can do. And then for most of the enterprise, yes, that's exactly the way you're gonna do. Okay, so for our Google Cloud VPC networks, it is global, and then the subnet are regional. So that means the smallest unit in our network is basically subnet. Okay, it's subnet. And then subnet is regional. So basically, that kind of design make you to be easy to do something regional. For example, you're going to run a website and you're going to have a lot of those workload, those VMs, going to run in different zones. And those different zones, yeah, some of the region, they have 3 zones, some of the region, they have 4 zones, but basically, most of the time, you will get all those VM evenly distributed into those different zones. And then if you're going to having some issues, for example, there are some zone having some issues, then what will happen? You still want to make sure your application is still available for your user, right? So in that case, what do you do? Pretty simple. You always have a load balancing in front of that, and then because the network itself, it's regional, right? So that will be easier for you to take in care and then easily just design anything which is a regional base. And even more than that, it's you can create something a global scale. So that means even when the region is down, don't worry, because those internal networks within even a VPC is global. So we can still find some way to actually route your traffic to those still available ones. All right, so before we move on to the compute engines, let's check something, which is a little bit quick demos. All right, so let's come and see this one. Of course, now you can see me. This is the user, of course, me, and then I have my project called Evelyn Demo. All right, good. So now let's look at our VPC. So you have the hamburger icon here, okay, because right now it's a lunchtime for me, and I'm here to show you something. So really focus on it. All right, so the VPC things, let's see. I've actually created something for you guys to check, is this one. All right, so this one is called On-Air Demos. Okay, this is the VPC, this is the name, and then you can see there's a whole bunch of regions. Wow, US Central 1, Europe West 1, blah, 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 blah. There's 22 of them. So basically means that we have right now 22 regions. And each of them, they have their own subnets, okay? So now you can see the subnets. This one is automatically created, and then it's always expand to the world. And every single region, they will create one subnet. They'll create one subnet. All right, so for each of these subnets, one of the things that you might think about it right now is this one. When you have a subnet, and then you have a CIDR here, and then you set /20, that basically means how many IPs you can get in this subnet. And then you ask me like, wait a minute, if that's automatic created, can I do a change? And what if once I start to use and then at a certain point, oh my God, I need more IP, and then I just stuck there. Oh my God, you hate that. I hate that as well. Because if you do on Prime, that basically means there's a lot of things you need to do. Oh my God, that's a disaster. But one of the nice things here is in Google Cloud, those IPs you can actually extend. For example, let's take this one. So this is one of the subnets here in US Central 1, and then we have a range, and then you can just click on edit, and then you can see, oh, this one I can change. For example, I wanted to change it to 16. So now I will actually get way more IPs, and you kind of feels like, oh my God, is that going to have any impact to my existing workload on it? The answer is no. And of course, at the very beginning, basically the way that we do it's this is not going to clubber with any other subnet. So that's why you can do this. All right, so the easiest way, very easy, just do the change, check how much you need, do the change, and then do the save. And then boom, that's it. That's it. You just wait for the savings, and then there's nothing going to impact your existing workload. No, not at all. All right, so just do the savings. All right, so let's coming back to my VPC. I still have something I wanted to introduce. So other than that, what else you do? Oh, this one. This is the VPC. And then now you can see, this is the kind of the way I love, because in this way you only see that one specific VPC, and then you have all the regions here, and then you can easily to check if you actually reserve any static IPs. You have some firewall rules in this specific subnet, in this VPC, and then what's the routing tables, and then if you have any peerings here, and even you have some private access. Okay, so talk about this private asset things. I don't really have the slides here, but I do wanted to mention a little bit. Why is that? Because this is one of the easy and cool things that we have. Because we said, now you have a private one. What if you really want a super private? That means your VPC without an internet gateway. That means not connect to the internet. Because you kind of believe, come on, I just run a system which is totally internal. I don't need to really to have any connections with the internet. I just want them to be super secure. So without the internet gateways. But at the same time, you still need to talk to some Google services. For example, you wanted to create some video, wanted to upload to the YouTube, or maybe you wanted to just put something into cloud storage, or you wanted to publish a message to PubSub, for examples. So you wanted to have some interactions from your system to our services. Then what's the way you're going to do? So it's this one. We call the private Google access. This is the way that you can easily just open up that switch, and that belongs to every single subnet. You can have that switch, and then we'll be able to connect to our Google services without accessing internet. Yes. So let's just give it a try. For example, let me go with one of the subnets here. Okay, click on it and then still edit. Okay, so this is exactly the same place. So here's one of the click, which is the switch. Private Google access. Click on it, on and save. Then that's it. Pretty simple, right? Yeah, it is. All right, so now so far that's the demo, and then let's coming back to our slides. Okay, so we have the network. Now we have a little bit ideas about like how the network works, and then later on we will still talk a little bit about the network part, because right now we only have the VPC. Now we have some IP. Now we can get some virtual machines. So what's the virtual machines? The service is called Compute Engine, and we offer managed virtual machines. We have some high CPU ones, high memory ones, standard, and even shared code machine types. And of course, that comes with a persistent disk. And we have some different types. You have the standard one, we have a SSD, we have some local SSD. That means it's not going through a network to actually store the data, but actually a physical storage attached to the VM you are running. And then we can create some snapshot if you want to, and then we can resize disk with no downtime. You feel that, oh, I just read it, right? But seriously, this one, resize disk with no downtime, it's just simply amazing. What does that mean? That means on the fly, when your VM is doing something, you can just go to the disk and change the size and click on save. And then that is not going to affect anything that you're actually running there on your VMs. Wow, that's amazing. Actually, it is amazing. By the way, when we say resize, it's going up, not going down, right? Because when you wanted to minimize the size, I mean, there's nothing we can do. There's nothing we know that which part you wanted to like make it small. All right, good. So Compute Engine offer customer-friendly pricing. So basically, the way we count the price is like per second. Oh my God, that's a per second billing. So basically, if you wanted to save some money, then just click the stop buttons a little bit faster. Then you basically save some budget. Okay, so that's one of the case. It's per second billing. And we have some sustained use discount. So basically that means anytime when you're using our Compute Engine, running the VMs, yes, if you just keep using, for example, use it for entire month, then what will happen? We will automatically give you some discount. That's great. And even more than that, it's if you kind of found out, all right now I'm using Google Cloud Platforms, and then I have some existing workload running there, and then almost like every month I'm going to spend some specific kind of like size of the budget. And then in that case, you can go with a committed use discount. That means you just contact our sales, and then you can have some discussions, and then you might going to get a commit use discount. All right, and the second part is one of my favorite, because this one is preemptible. That's something really nice. This is a good use of the resource. Why is that? Because, I mean, cloud, right? We have so many resources, but believe me, it's not unlimited. And then most of the time, it is full. Wait, what you just said? Yeah, I just said most of the time it's full. Like, how come it's full? Then where can I get my resource? So basically, for those VMs, there's two types. One is called on-demand, you pay for the full price. And then second is those one, we call it preemptible. So the preemptible one, it's 80% discount. Wow, that's nice. You only pay 20%. You get exactly the same thing. But at the same time, there's pros and cons, pros and cons. So what's the cons? Of course, this is an interruptible workload. That means at any time, if we need those resources to give it to those users who pay for the full price, which we call the on-demand, then we will take those resources away from your project. So that's why we said preemptible, or you can say interruptible workload. All right, so this is the one, if you kind of like wisely to use them and leverage them, you're going to save a lot of budget. But at the same time, yes, it's interruptible. All right, so if you do interesting about how to use that one, join our session tomorrow, because when we talk about the big data part, yes, we're actually going to leverage this preemptible instance. So third one, high throughput to storage with no extra cost, and then custom machine type. Only pay for the hardware you need. And this is something also really cool. Why is that? Pretty simple. Because now you can just decide you want like 6 core. Is that going to happen? Yes. It's not like a fixed size that you have to go for 4, 8, 16, that kind of things. No. It's just that we can easily to cut that specific size, the size you want it, you define it, and then give it to you. And that means under the scene, under the hood, what happens is we do not predefine those size and then give it to you as options. We basically, yes, we define something that's the best practice because that's easily for us to cut those resources. But if you wanted to have some specific kind of size, yes, we can just dynamically go and have that happen and then give it to you. So basically that means under the scene will be way better to do those resource management, okay? Because anytime you need anything, any size, we just file the physical machines and then do that cut and then give it to you. And that's better. All right, good. So several ways you can do for the compute engine. Of course, you can go with a huge one, which is a big VM, which is a lot of memories, and that will be a compute intensive applications. Or you can go with auto scaling. That will be for those resilient scalable applications. All right, good. So now we talk about the virtual machines, and then now let's talk about some more important VPC capabilities. So you control the topology of your VPC network. And this one, of course, you use the route table to forward the traffic with the network, even across the subnet, and then use the firewall to control what network traffic is allowed. And then you use a shared VPC, that's the one I've mentioned. You can share with the entire network or the individual subnet to other GCP projects. But for this one, have to be within the same organizations. And you can use VPC peering to interconnect network in GCP projects. So basically, if you still have 2 projects, or even those 2 projects belongs to 2 organizations, and they wanted to talk to each other using internal IPs. I mean, why internal IPs? Of course, it's low latency, it's second, it's more secure, and it's even cheaper. Yes, it is cheaper, okay. Because for our network, the pricing, it's the network fees, and then there's an internet access. So if you go for external IPs, then there's an extra cost. All right, so free benefits. So you wanted to do something like using internal IP. So then in that's the case, you do the peering. So you can do the VPC peering in that kind of cases. All right, so with the global cloud load balancing, that's the one. That really make your application able to face the world. So now you can present your application in a single front end to the world. So what is that? So that will get a single global anycast IP address. And that's cool because that specific one global anycast IP address is going to be the one that everyone around the world going to connect to it. And then what we do? The traffic go over the Google backbones from the closest point of presence to the users. So basically, if you have users which is in New York, in Germany, in Tokyo, then what will happen? Pretty simple. If that's one single application or website, then they are not going to use the internet to find the one specific place that you have the resource and then start to access. No, they're actually going to find their closest point of presence. For example, in Japan, they have their point of presence. So the Tokyo user still going to use their ISPs, but then have a very short distance to find that point of presence that we own as a network access point in Japan. And then they can access, then all the rest is Google internal network. Wow, that's cool, because in that case, anything is just on the highway, and then that's super fast. And in that case, it's like we are so smart that we can just make that Tokyo go with the point of presence, and then if you're actually running some backends in Japan, then they will just route it to Japan, which is the closest one. So when you have the closest one first, the point of presence, and then the closest region, then you always get the best response time. So low latency basically means what? User experience, of course. Yes, so that's kind of the case. And then we said backends are selected based on load, and then only healthy backend receives traffic. So basically we will do the health check for you, and then you can set up some policies. So only those healthy ones going to get some traffic. And when we talk about the backend are selected based on load, what does that mean? I mean, just imagine you're actually running an e-commerce website, and then it's a global one. You have them in US, in Europe, and in Asia. But then, because US is doing some promotions, and then they just love your website, and then a whole bunch of people just join in. And what happens? Oh my God, your backend is not enough. It's full. Wow, what happened? Are you going to let that more users that comes in and then maybe will crash your backends? Not really, I don't think so, okay? You rather just let those people are in the shop, keep shopping, but then just stop a little bit, those people come a little bit later. So what do you do? But you're still having some resource, maybe they are in Europe, and then you still have resource, you want them to go to Europe. So what do you do? Pretty simple. If you do the policy correctly in our load balancing, yes, you're going to do that. You can automatically do the check on the load. We know that, oh, US is full, although those customers coming from US, we should bring them to the closest region, but that one is full. So what do we do? Pretty simple. We will automatically route them to the second closest one, and most of the time should be Europe, and then they will go to the Europe backends, and then they will still able to do the shopping. And then it's a win-win game for your customer and you, of course. And by the way, for our load balancing, there's no pre-warming which is required, and that's nice. That means you can rely on our Google Cloud load balancing and as a place to get all the requests. And then the only thing you need to define is making sure you will have the backends and then to speed up with those coming in or growing loadings. All right, so what's the kind of offering we have for the load balancing? Let's check. So we have 1, 2, 3, 4, 5. We have global HTTP, we have global SSL, we have global TCP, and regional internal. So I think most of the common one is the global HTTP one, because this one, anything you build on top of HTTP or HTTPS, that's the one you do. And this is the one I've mentioned. I just give you the example, and that's the one. And this one also really nice to have a URL mapping. That means you can decide what URL goes to different kind of backends. So that's nice. And in some case that you're actually not running anything which is HTTP based, maybe something like a layer 4 with SSL still secured, then you can go for this one, global SSL proxy. And there's a third one, which is global TCP proxy. This one is also layer 4, and this is the one that when you are not able to go with SSL and it's not HTTP, but still based on TCP, yes, then you can do it. And 1, 2, 3, those three, which is HTTP, SSL, and TCP, those three, they are proxied. So that means all the traffic comes in, we will cache them first, and then the session ends, okay? The package comes in, the session ends, and then that's the proxy. Then we will check, we'll validate, we make sure that's the valid package, then we send it to your backend. So basically, we have the protections for you for a backend. But then the rest of two, which is regional and regional internal, those two, I'll say, yeah, those are the regional things, and then those two are not to be accessed by those point of presence. So they are not go for those global kind of use, but those two, they support what? Oh, instead of just TCP, they also support UDP. And those two, they are passed through load balancings. So basically, there's no proxy there. Every single request comes in to those regional or regional internals. They will just pass through and then hit your backends. Okay, so those two, be very aware. So we have two kind of them. We have those global ones, and then we have those regional ones. And then just ask you one question, do you think that if I do something like regional, for example, I just wanted to go for one specific country, which is a specific market kind of applications, are we going to use the regional one or the regional internal ones instead of the global ones because I'm not global? Oh, come on. Global ones, of course, you can use it still in those regional ones, okay? So most of the time, it's still go for those global ones because that one brings you the point of presence, that's the premium network tiers, and then that one have a whole bunch of nice features, and then you can always use for regional use as well, okay? Cool. So, Cloud DNS. So of course, to let your user able to find you, you use the DNS service. And then here at Google, we also have that. We have a Cloud DNS, which is a highly available and scalable ones. And this one is simply nice. And then most of you guys might use before already. For example, like 8.8.8.8, if you heard about that before. That's exactly the same thing. That's exactly the DNS service, the service that we provided to the public, to everyone they can use. But if you want your application, your website actually having that kind of like highly available and scalable, then go for it. We have the service here, and this one have the SLA with 100%. And Cloud CDN, of course, which is the content delivery network. And in this case, yes, you might want to do some cache. For example, some we call the edge cache, that any kind of static content, like an image, like an audio, that kind of stuff. For example, like YouTube videos, we actually have a huge video and then we cut them into small little pieces. And those little pieces, they're actually cached though in those CDNs. And then so that's why most of the time when you're actually going to load those like a pretty common videos, it's actually quite fast. Why is that? Because you don't really go connect to the data center to get those videos, but actually just go to the cache and then you will get all those little cutted pieces and then all combines together. Then it's your loving videos. All right, so that's a CDN. And other than that, we still mention that we doing hybrid cloud, private cloud, or those hybrid cloud kind of things, right? When I say private, it's not like you really do some private things. It's like you can do those virtual private things on our Google Cloud platforms, right? So how you do those hybrid kind of things, or even you wanted to do some multi-cloud, that's the one. You need some interconnect options. So the first one is VPN. You can have a secure multi-gigabit per second connection over a VPN tunnels. So for that one, it's nice, and then we actually give you an SLAs as well. And if you need something like more throughput, you can have several VPN all combined together and then use it. Or a second way, if you really want to speed out a little bit, for example, you want to having your on-prem network and our Google Cloud network be a little bit like a shorter distance in the internet, then what do you do? Pretty simple. Now you actually want to go for peerings. When we talk about the peering here, it's not about like the VPC peering. It's a little bit different. So the peering here, we'll talk about those peering of your network and our network on the internet. So basically, once you've done the peering, you're still not able to talk to each other using internal IPs. No. But the distance between your network and our network on the internet, it's shorter. That's it. Pretty simple. Okay. And the difference between the direct peering and the carrier peering is one direct peering just comes straight to us. Yeah, that's the one. You can straight connect to us, or the carrier peering basically have a partner network in between. So you connect to the partner network and partner network connect to Google. So that's kind of the case. And then other than those two, we also have interconnect, which is one called dedicated interconnect and partner interconnect. And those two are the ones that really give you the underlying kind of almost like a physical connections, which is layer 2, layer 3 kind of things. And that one give you like a really like a dedicated backbone, that size that you can go for it. So that's kind of things you can do, of course. All right. Wow, that's a lot of things already, actually. So we do also always having some documents, go and check them always, and always a lot of updates, especially for the load balancing part. I do suggest go and check, because for the load balancing part, we recently just have a lot of new announced, and then we have some feature in beta, but they are really cool. They are really cool. All right, we still have some more things we need to talk about it, which is our storage. Yes, of course, we still need to have some storage to talk about it. So now let's see. So when we talk about the Google Cloud Platform, and then now we know the network, and then now we know the computations, and then we even know like the load balancing part. So now what else? I mean, come on. If you're going to run any workload, of course, you need some database. For example, you're running a game, you need to memorize who is who, and then who is what role, and then how many coins they have, that kind of stuff. All right, so those kind of things, yes, you do need to find a way to taking care, to store those, maybe a metadata, or maybe some structured data, or even you want some like a video, image, those kind of stuff. So we're going to introduce those 5 different options that we have. This is not the only 5 different options, but that's what we're going to talk about today. So cloud storage, cloud SQL, cloud spanner, cloud data store, and cloud bigtable. So the first one is cloud storage. Okay, so cloud storage is the one that really amazed. And then just share you guys a story before we jump into it. It's cloud storage. Under the scene, it's actually something we call the Colossus. Okay, and Colossus, that's the 2nd generation already. There's the 1st generation actually called GFS, which is called Google File System. And then why we invent that kind of like a Google File System? Pretty simple. So really back to like 20 years ago, at Google just started. When Google just started, what's the first service we have? I believe most of you guys actually know the answer. It's Google Search. Yes, exactly, it's Google Search. So Google Search itself, it's our first service, and the first service have so much challenge. You know what? A search engine, yes, you crowd all the information from the internet, and then you need to save them, you process them, you make it index, make it searchable. But you know what? The first challenge is actually the first thing I mentioned. Oh, not the first thing. The first thing is to crowd it. And then second thing is like store them. Wow. Just imagine if you need to crowd all the data from the internet, entire internet, and then save them. How much data you have? And kind of imagine what's the kind of way you can actually save them. Wow. So that means you actually need a storage able to scale and keep scaling, and they have to be fast and have to be cheap. So basically, that's our first challenge. And then we know that at the time, any existing technology is not going to support us. No. So we need something more. We need something nice. So we kind of create something. Of course, we based on a lot of research, and we create something called Google File System. And the Google File System is the one have a distributed like a storage, so you can easily to scale out. And then other than that, to make us actually able to search, is like you need to do the processings. So processing, we have MapReduce, which is also another paper that do parallel computings. And then once we're done with those parallel computing things, then what else we do? We need to make some index and make it data sorted, so then you can easily to search. I mean, if you type your name or you just type Google on the Google search, you click on the bottom, how much time are you going to spend to get the answer? Like less than a second? right? So that's kind of the things. And imagine how many users are actually doing the search exactly at the same second. Maybe a million, maybe a billion. Wow, that's a lot. So for that, we need a way to support that. So we actually have something called a big table. And that's also one of them. We are going to talk about it later on. So this is how we make it. So this is what we're going to talk about. And you see, we have so many papers, and then those are the cool technologies. And then now, if you're using Google Cloud Platforms, basically you're actually going to use them. So that's nice. So let's jump into it. So cloud storage. It's a binary large object storage, and this one with a high performance internet scale with simple administration and does not require any capacity management. And why is that? Because it's never full. It's never full. It's almost unlimited. But I mean, basically, there's nothing unlimited in the world. I mean, nothing unlimited. So that means when we purchase those disks, it's way faster when you store your data. So basically, that's the idea. All right. So we buy a lot of like disks. Okay, that's true. So you do not need to have any kind of a capacity management, and then every data is encrypted at rest. Yes, it is encrypted at rest. And then the data encryption in transit is by default from Google to endpoint. And we have online and offline kind of way to import the service. And the cool things here is the durabilities, because first, we need to make sure the data is safe and is stored, and then we can start to process them, and then we make it searchable, and we make sure they are not like getting lost. So the design, by design, the annual durability is like 99.999999999. So like 11 nines, okay, whatever, so many nines. That's really, and that's by design. So you can see that that's the way we store our data. And then believe me, even like YouTube, even like Gmail, even like Google Photo, we have a whole bunch of data every single day, several petabytes, even more. It's all under the same technology that you use here for cloud storage. All right, so that's the one. And then for your cloud storage files are organized into buckets. So the way we describe those data, or you set the object in the cloud storage, we use a bucket. So there's some bucket attributes here. We call it first, there's a global unique name. And second, you will have different kind of storage class. And you will have a location. You can choose regional or multi-regional. And that's nice, because that means if you choose regional, all the data is across the zones. If you choose multi-regional, then all the data is across different regions. Yeah, pretty simple. And the way we control those assets, of course, is IAM. That's always you can do. And second, if you want something like down to object levels, then we'll still have something you're super familiar with. It's the access control list. All right, which short it's ACL. All right, so that you can do. And other than those two, we also have some more features. For example, like object versioning, and that's nice because basically for cloud storage, any kind of things, those objects you put onto it, yes, it's actually going to just be there, and then it's actually hard for you to do some edit. You cannot just open up and then do some edit in between and then put it back. No, you basically get it down, you do the edit. When you put it up, for us, it means a newer version. So you just call overwrite. You just overwrite. But if you wanted to keep all the versions, yes, you can. So you will just enable this object versioning settings, and then once you're done with that settings, basically we will keep every single version, and all the versions are going to be keep it there. Yes, exactly. So that's kind of the case, but just be careful. When you enable the object versioning, that means if one file is 1 gigabyte, 10 version of 1 gigabyte, it's 10 gigabyte. Pretty simple math. So that means you have to pay for those storage. Okay, so cloud storage, the pricing part, you will check the documents, but basically it's how much you store, how much you pay. All right, and other than that, we also have an object lifecycle management. And then I'm going to do a demo later on for that, and that will be really fun because in that case, there's a whole bunch of like super nice policies that can save you a lot of cost for your storage. And for the bucket content, what we have, files, in a flattened space, and then of course you have the access control list. So let's see, which is the most important thing here for the cloud storage is actually choosing those different classes. So for location-wise, you have multi-region and regional, and then most of the time, instead of just location, one of the storage class is called standard. Although not listed here, but you can just treat them like a regional and multi-regional. Those two are the standard ones. Okay, for the standard ones, yes, they are very nice, and then the price is like a little bit higher for the storage, but there's no cost for retrieval. All right, so you can see this chart here basically give you some ideas about what's the availability SLA, and then for the SS API, it's just all the same, and then for the SS time, all of them are milliseconds. It's just the same. So it doesn't matter what's the storage class you choose, the SS, the API is just the same. The only difference is how much you need to pay for it. Because more left, you have more storage price. More right, you have more retrieval price. So on the left-hand side, multi-region and regional, if you go for standard, then there's no charge for retrieval. But if you're starting from nearline, cold line, or archive, those three kind of storage class, yes, you will get retrieval cost. So every time you read those data, yes, immediately exactly the same API, exactly the same access time, but you are actually having some retrieval cost. Okay, so beware of that. So those are for more like different kind of use case. For example, for those multi-regional or regional, I'll say just go with those hot data. And then if you wanted to analyze something, I will say go for the regional ones. Okay, for regional ones. And then if anything like a long tail content or even something like a backup, go with nearline, anything like archiving, maybe cold line or archive. Okay, and archive, one of the special thing here is we don't have the availability SLA. Why is that? Because later on when I do my demo, you're actually going to see that the price is like unbelievable low. It is. So for that, we still give you the SLA for the durabilities, but you don't have the SLA for the availabilities. All right, because we kind of believe, I mean, by design and by your choice, you know that's an archive. So archive, most of the time, you don't need to. And then when you don't need to, sometimes you just don't need it immediately. Okay, so that's the kind of case. That's the kind of case. All right, so for those access pattern, I will say like if you access less than once a month, then nearline, and then cold line for once a quarter, and then archive once a year. All right, good. So here we do have some kind of ways that you can bring your data into cloud storage, and then you have the online transfer, or you have a storage transfer service, or you have a transfer appliance. And then for the online transfer, it's pretty simple. This is like self-managed, and you just use the command line tools or use our consoles to upload the data. And then for the storage transfer service, this is the one that if your data is in somewhere, internet, or network able to access, then you can use that. For example, you have a URL and then that points to a specific data, you can use that to bring it here. Or if your data, for example, is in another cloud providers and then that's able to access, so then you will give us the credential and then we'll help you to get those data into cloud storage. Or in some case, for example, on-prem, you have some data you wanted to bring it up, and they're like terabyte or petabyte or even more. Wow. Think about it. If you actually have a petabyte, and then you are going to use your 4G network, okay, to transfer that petabyte of data, do you know how much time you need to spend? If you go over like internet with a 4G network, sounds good. It's something like 27 years. I mean, seriously, that's a little baby and it's an adult right now. All right, so you're not going to do that. So basically, you're going to use a transfer appliance. What is that? So we'll actually ship you a physical machine, and then you're going to get your data all into that physical machines and then send it back. So that's, I always said, that's the case when your flight or when your train is faster than your internet. Okay, so that's kind of the case here for the transfer appliance. All right, so we said cloud storage work with other GCP services nicely. And of course, you can keep your data in cloud storage and use it everywhere. And that's a super common thing to do here in Google Cloud Platforms, because that's a nice way to stage your data and then just keep it there in cloud storage. And that one have the lowest cost. And then at any time you need those data, just go for it. Using the App Engine, using the BigQuery to analyze it, using the Compute Engine to access some of the data, or even have a Cloud SQL to do something. Yes, there's a lot of ways you can do. So now, let's still back to our demo, because now still something I do wanted to show you, which is the cloud storage. So if you go to the hamburger icons again, and then now you get the storage, so click on it. All right, so you can see that I have a whole bunch of buckets here. So let's create one for today. Okay, let me make it bigger. All right, so let's say I wanted to create something, and then my name is Evelyn, and I want to use Evelyn, and then I tell you this is globally unique, and then I use it before, and I use it somewhere else, so it's not going to use it. You need something unique. So let's say on air, and then now it's 2020, and it's March, and today is 24, I believe. Okay, so now we have the bucket name. And then now we're going to choose the location. So location-wise, you have regional, you have multi-regional, or you have dual regionals. Okay, and check on the right-hand side. Here's the storage price. Okay, here's the storage price. This is per giga per month. So 0.026 for multi-regional. If you choose regional, then the price will change. So that's actually the price for standard class. So let's go for regional. All right. So regional, you can still choose location. You can choose in US or in Europe or in Asia. So let's say, for example, I'm in Singapore. Let's get Singapore. All right, so every single region, they actually have a different pricing, so be aware of that. So when you choose, just go again and check. So now, because it's standard class, so there's no retrieval cost. Continue. So now we're going to choose the default class. So the default class here, you have standard, nearline, coline, and archive. For the standard, yes, that's the price for the storage, and then it's free for retrieve. But once you move on to, for example, a nearline, wow, what do you see? Yes, now you're going to save some money for the storage because we just dropped you 50%. Wow, that's nice. But at the same time, you will see that we actually having those data retrieval cost. Wow, okay, so starting with nearline, you have the retrieval cost. Then you will ask me, wait a minute, so in this case, I actually pays more? No, it depends on how you use. If you keep data in nearline and then most of the time you don't actually going to access, then you save a lot of money because something you always pay is the storage, but the retrieval is only when you do the retrieval, then you pay for it. And of course, here we have something even more, which was code line, and that's half again. So now you have a higher retrieval cost, and even more for the archive one. Wow, that's crazy. It is crazy. Yeah, the cost, it's even lower. Oh my God, what is that? 0.0015. Oh my God, that's a super cheap. But this one, you can see that the data retrieval cost is actually quite high. So this is really the one that we said archive. Come on, it calls archive. So of course, that's the one you're going to use it for archive. So let's go for this one. Let's just do the standard because most of the time we do standard. And you'll ask me, wait a minute. So is it like the one single bucket have that specific storage class and then I cannot change? I have to move my object to another bucket to change the storage class? No. Same bucket, different object can have different storage class. Yes, you can do that. Yes, you can do that. Okay? So that's kind of the way. It's just called a default storage class. So that means every single object land in your bucket, that's the default storage class. Sounds good? All right. So now we have the Control SS, we'll just choose the fine grained, and then even some additional ones, you can do some management for the Google managed keys or customer managed keys, or even you have a retention period. Okay, so those are the things you can do. All right, so now let's just create. So click on it, create, The bucket name enter is taken. Please try another one. Oh my God. Okay, I kind of believe someone is actually doing demo at the same time, or just wanted to try. All right, it's okay. I'll put on Efi, and then I don't think this one is going to be the same. All right, it's okay, it's okay. All right, just follow me with the demo. Why not? All right, so now we have this one on air and a specific day, and with Efi, that's a name. Just for demo, it's okay. All right, so now I get this bucket, and now I can start to put things on it. You can upload, or you can use some command line tools. So let me see. Now let's check what's one of the things that I do mention it and that I love it is this one, which is called the, so here I'm going to click this on, but on top, this one actually shows you life cycle rules. All right, so that's the one I mentioned it. So let me click on it. So this is the one of the amazing place that you can add up some rules and it's totally free. And then we will, based on your policies, based on your rules, to automatically going to change those different kind of object storage class. So for example, let me give you one of the examples that, okay, you have a customer service and then you have some user logs coming from your users because they're using your app online. And then what happens is like, oh, within a week, if they're having some issues, yes, they will come and call you and then you need to check in the system and then get those user behavior logs and then you can see what you can help with them. But you know that once 7 days pass, then there's a very little chance they will come, but still. So you might want to find a way to store those data in a little bit cheaper way because you are not going to retrieve that much. And then later on, you know that within a month, if once pass a month, then the data have a very little chance you're going to access. And even more is once the data within a year, you kind of feel it's like almost 100%, like no one come and actually need for that. But based on your compliance, based on your regulations, you still need to keep them like a 3 years. So what do? Is there some ways that you can make that happen automatically? Yes, it is. Just this one. So let's add some rules. So I'll say the first one, we said 7 days. So I'll say age. The age of the object once land in your bucket, that's the age. So I'll say 7 days. Once 7 days, anything in fresh before 7 days is standard because that's our default storage class. Then once hit 7 days, what we do? Put them into near line. Why not, right? So now we put them in near line. And then let's do a second one, still the age, because we know once hit 30 days, what happens? It's very little chance. So we might going to go for a cold line. All right. And then we said, oh, what about like 1 year? Oh my God, 1 year. Okay. So I believe that's almost like no chance. So find an even lower cost for the storage. And then of course, at the end, we believe that, oh, anything around like 3 years, I'll say just 1,000 days, then we can just delete it. Boom. Now you see, this is the rules. And once you're done with the rules, this one actually needs to spend like 24 hours and really actually able to start to running. And then all the rest of things, you just keep putting all new objects into it. And then when they actually hit any of those rules, then they will just do their things and then change their storage class. All right, so by the way, you should actually see those pop up on our platform and asking a few questions. So please take the time to answer them. And then later on when we finish, then we're going to answer those questions live. All right, so let me just simply show you one of the case that we have some different storage class. So for example, I have one of my buckets here. There's an earthquake. This is something I've done yesterday. You see, the storage class is nearline, storage class is archive, So you can easily to see that, oh, in the same bucket, different kind of storage class. And then you cannot change the storage class on console, but then using a command line is actually something pretty easy, okay? So for example, the easiest way that you do is like this. Using the command line, click on it, my Cloud Console comes out. So, Cloud Shell, my favorite part. And then we always need to wait for it a little bit. And then once it jump it up, then we can run the script. Okay, so now let's make it bigger. All right, so see that it's me using efi, and then it's under efi-link-demo project. All right, so now we can do a little bit like a ls, which is to check something, okay, to check our bucket. So what is there in our bucket? So this is the way, pretty simple. And then I'll just go and check this one called earthquake. All right, and then with some stuff in it. So if now you wanted to change something, for example, you wanted to change the storage class, for examples, then what do you do? Pretty simple. You have a command called gsutil rewrite -s, and then define what's the class. For example, code line. And then now you have to define what's the specific ones. Okay, let's check here. All right, like this. Now you see one. Okay, so this is the one. Now we have the CSV. Now it's in nearline. Let's put them into different class. So let's put them in code line. So the CSV one, copy paste. Boom. Now things are changed. Cool, it is. And then of course, now you just refresh. And then you can see it's code line. All right, so it's actually something pretty simple. But then just beware. Once you put things into code line, nearline, archive, there's a minimum durations. That means that's a minimum cost. Okay, it's just like if you go to a restaurant and then there's a minimum charge. Okay, for code line, nearline, and archive, there's a minimum charge as well. So by the way, for that one, you just go for check out documents and you will see. All right, so that's for the cloud storage. So now let's move on to cloud big tables. So cloud big table, it's something we have mentioned it. If you have a huge amount of requests to do some read and writes, then that's something you do it. And there's an open source version called Apache HBase, and we are compatible with that HBase API. All right, so this is the full managed one, and it's NoSQL, and it's white column database service with petabyte applications. And why choose Cloud Bigtable? For example, first, we're taking care of the replicated storage, we have the encryption in flight at rest, we have role-based ACLs, and we drive those major applications, such as like Google Analytics or Gmail. Okay, so even something like if you know that Google Map, we have a street view, right? Those street view, that kind of like things, it's actually stored here in Bigtable. Also pretty cool. All right, so some of those access patterns, you have some application APIs, you have some streaming ways to access, or you have some batch processings. That's also able to do. And it's really working nicely with all those big data open sources. So, other than that, of course, now we have the binary file to store, and then if you have some like IoT, that you have a whole bunch of devices, kind of like sensor, need to do some update at the same time. When I talk about sensor devices, maybe like 1 million, right? So that's kind of the size. So 1 million devices wanting to do some update at the same time. Oh my God, that's hard. So for that, you need something like a big table, because that one can scale, and then that one can take in care a lot of requests, a lot of reads and write at the same time. But now you need something, for example, your traditional workload. For example, you want something like a transaction, that kind of things. So, of course, still using the normal ones, which is MySQL, Postgres, or even we have a SQL Server now supported, which is in beta. And then the Cloud SQL is the one with the managed relational database. And this one gives you automatic replications, managed backups, and vertical scaling. But this one, it's with downtime. That means you can just go and change and then click on the bottom, then we will help you to drill down and then change the type and then come up again. All right, and for those horizontal scaling, yes, you can go for read. So you can have some read replicas, and that's something, yes, pretty cool. And of course, the security is still IAM. Yes, IAM, that's the one. That's the one we do. And of course, Cloud SQL itself, we support some more features like you can have the private IP ones, and you can go with some gateways to actually go through to do the proxy, to do the authentications, instead of just using the IP to do some restrictions. So there's a lot of things we can do. And some of the ways that you can use Cloud SQL is here, like you can have the app with App Engine, or you can have them with our compute engines, or even some other systems as well, some external systems. Okay, so those are different kind of ways you can do. And of course, in some kind of case, I mean, just believe that things are kind of changing. The world is changing. It's changing all the time. So like MySQL, Postgres, those kind of like database, they are nice. They are super nice. They support all bunch of things, and then they are good. But one of the issue is once the data become that size, too big, then it's super slow. So, for example, we do have a public reference case, which is called Quizlet. So they have a website, and then they are running MySQL before, and then they have a lot of concurrent queries to support their users to do something. And then when there's too much users online at the same time, that means a lot of query at the same time. Their MySQL still working nicely, but the latency becomes quite high. That's hard. So when the latency becomes high, that means the user experience is not that good. So in this case, what do you do? Pretty simple. It's like you wanted to do, for example, you wanted to do some sharding. You wanted to kind of like, make that one table to become separate tables and put them into different machines. So then you can evenly distribute those workloads. So either the write or read, you can evenly distribute it. But that's a hard thing because every time you wanted to do some shardings, there's a downtime, you need to do some planning, and then you need to do it. So that's hard. So at the end, what they found is this one, called Cloud Spanner. This is the one that have horizontally scale, and it's a relational database. And for me, myself, I always call it Superman. Because, yeah, that's the Superman, because that one you have the high availability, 5 nines, 99.999, and then strongly consistent, and it's a global plan, strongly consistent, and then it's scalable. How scalable? Pretty simple. If you have that kind of case that the latency goes up, what do you do? Pretty simple. Go to the console, change the number of nodes, and then click on save, and then just wait a little minute, and then we will just do all the rebalance, all things under the sink for you. Boom. The latency just goes down, and then nice and peace, and then everyone's happy. So that's Cloud Spanner. But of course, it's a Superman. So you will get the Superman price. So that's kind of things. We do have those kind of service for you to support some very extreme kind of cases. Yes, and it's nice. But of course, you will actually think about it if that actually fit your needs. So this one have automatic replications, strong global consistency, managed instance with high availabilities, and of course, the most important things, it's a relational database. You can define reference keys, and then you will use standard SQL 2011. Okay, very good. So other than those two kinds of like a database that you actually do things with, SQL. Now there's a non-SQL one, which is called Cloud Data Store. And this one is actually pretty nice. Why is it nice? Of course, this one is one of my favorite game. Actually use it. It's called Marvel Run. So I don't know if you ever heard about it. That's a very nice like mobile game that, I mean, Marvel things is being for a long time, haven't get something new, and this is something pretty cool, and I love it. And they build things on data store, all right? So, by the way, we do have some pop-up questions. I think you guys saw that already, but I mean, just take some time to answer that, and then later on, yeah, we will talk about it. All right, so the Cloud Data Store. So Cloud Data Store is the one that the Mario Run, they use it, and then they actually run those games on App Engine as well. So that's something we will talk about it later on. But for storage, they use data store because yes, you need to save all the information for all the users, and then you make sure the coins are correct. I mean, seriously, I'm really serious about all my coins because you can buy some more icons, more kind of tools. That's very important things, okay? And that's a transaction. So you actually need some kind of like a transaction support, and that have to be super scalable. I mean, imagine how many users are actually going to play that game. You can't really control, it's hard. So they choose App Engine, super scalable, and then under the scene, the database have to be super scalable as well. So that's the cloud data store. All right, so let's check. Cloud Data Store, it's a horizontally scalable NoSQL database, and it's a NoSQL designed for application backends, and it's full managed and use a distributed architecture to automatically manage scaling. And we have a built-in redundancies and support ACID transaction. Okay, so that's very important. Support ACID transactions, and this one, it's horizontally scalable. But be careful, it's NoSQL. But we still have some kind of APIs for you to define what's the kind of data you want to retrieve. But yes, it is NoSQL database. So NoSQL database means, sorry, you don't have the SQL interface. And here, the benefit, it's a schemaless access. No need to think about underlying data structures. And this one automatically scale. You don't need to even go and provision like I need more nodes. And then local development tool is supported, and we even have some free daily quotas. So of course, if you want something small, with the App Engine, you get some free quota. This one, you get some free quota, so both free quota, so you can start something small, and then there's no cost. And we can access from anywhere through a RESTful interface, and that's just nice. All right, so that's the cloud data store, and then let's compare our different options here. So all things in green, those are the very scalable ones. You have cloud data store, you have cloud big tables. Those are the two things which is both very scalable. And what's the use case? You can do something like an App Engine application, and anything you need transaction go with the data store. That one very scalable. But at the same time, if you actually need to support like super lot of client, doing some update very often, a lot of read, a lot of write, that kind of things like ads tech or financial IoT data, then Bigtable will be the great fit. And other than that, of course, anything like binary cloud storage is just the right ones. Really nice with the pricing. There's a whole bunch of different classes you can do, and this is just simply nice. And that's always the nice place to do any archive, any backups. Then Cloud SQL and the Cloud Spanner is actually the one. Cloud SQL, Cloud Spanner, this is the one to support any kind of relational SQL for OLTP. So yeah, you do transactions, all right? So those are the two supported transactions, and then we said the Cloud Spanner is the Superman, and that one is more like if you go need with those kind of global kind of cases, global plan, you need global consistent, you need something very scalable with very high IOs. Yes, that's the time Superman come and save the world. So now you get the Cloud Spanner, all right? And other than those 5 things, we still have BigQuery. Oh, wait, what is that? It's not mentioned here. So we will actually talk about BigQuery tomorrow. That's actually one of the things that we make it ourselves, which is the technology coming from Google. It was called Dremel as a paper, and then at the end, we make it become a service called BigQuery. That one supports standard SQL to analyze huge amount of data and with very limited amount of time. For example, you can query something like a 1 petabyte, not a big deal, 90 seconds around, then you get the answer. Wait, 1 petabyte? Yes, it is. 1 petabyte, 90 seconds, you get the answer. And that's the size we need, because that's actually the tool that internally in Google we use it to analyze our data. Because that's the size, in Google, size are always big. Anything scale is global. That's the case. And that's BigQuery. So if you do want to hear a little bit more about that, come and join us the next day. All right, So a little bit more resource, of course, and always suggest you guys to go and check out documents. And then other than those things here, I do also suggest if you want to dive deep a little bit more about our specific services, just use wisely with our best product, which is called Google search. All right, so Google search, if you go for it, I always love to type GCP, release note, and then the specific service. And then that will bring you all the timing about every single new features for the entire timelines for that specific service. And that will be something pretty cool. You actually to see how we kind of keep doing those innovations and then to do those improvements. All right. So now, I hope you guys do actually have a little bit of time here to do a little bit like a Q&A, because I think I kind of remind you guys like very late. But I mean, I hope you guys actually having a little bit of time for that. So, the first questions. Google Cloud Load Balancing lets you balance HTTP traffic across multiple compute engine regions. Is true or false? The answer is true. All right, so this is the one we mentioned, HTTP traffic. So that's the global ones, and then that's the one we talk about, the use case that you have a website or an application which is global ones, and then you have them in US, in Europe, in Asia. And it doesn't matter if you both all have some backends and then your user coming from everywhere, we will just automatically just route them to the closest one. Okay, so that's the nice one. And remember, you're still able to use something we call the global, but you can still do those regional things. Okay, it doesn't matter. It's just about what's the tech behind. The global itself doesn't mean that you're only able to use it for global. All right, cool. So this one is true. Let's see the second questions. So the second question is like, oh, your stream huge amount of data from device and sensors. Wow, a lot of keywords, device and sensors. And which storage service should you consider first? All right, so when we talk about huge amount of data and it's streaming and with a lot of device and sensors, because that we said is stream and it's a lot of end devices. So I say the only answer is the big table. Okay, the big table will be the one. All right, I see that we still have a lot of people that are actually choosing another one, which is cloud storage. Okay, so I would say cloud storage, yes, it's a nice place to keep all the binary files, but if you're streaming, when you do streaming, it's more like a small message. Okay, small message. So those small messages, those kind of things, you don't put them into as a file. You just put them straight to your database. For example, big table will be the good fit. Okay, so right now here should be big table because you're dealing streaming and it's devices with sensor. That means a lot of those kind of like clients. And by the way, big table have the best low latencies. When we talk about low latency, it's something like a 6 millisecond. Wow. Read and write and billions at the same time, 6 milliseconds, that's impressive. Okay, so that's why we said streaming, you have to go for that. All right, next questions. So your application transcode large videos files. Oh, come on, video files, right? So video files, they have to be exactly just one answer you can choose. All right, so that'll be cloud storage, right? Because video itself is a binary file. So of course, go for that. And I did mention something like a Google Map for the, you can store the street view kind of things in the big table, but that's more for like those keys. So once you get those keys back and then those images, they are still in cloud storage. So that's kind of the case. So all the kind of binary files go for that. All right. So I hope you guys all enjoy this module, and then I hope you all answer correctly. And thank you for joining our digital event. So please stay tuned for our next modules.